10.1 Area of parallelograms. So the definition of area of a figure is the number of square units needed to cover it without any gaps or overlaps. The area of a rectangle is the product of the length and the width. The rectangle shown has an area of 12 square units. For a rectangle with length L and width W, the formula is A equals length times width, or simply A equals LW. So here we have a length and width of 3 and 4, and if you multiply 3 times 4 you get 12. That is also the number of square units in this rectangle. Recall that a rectangle is a special type of parallelogram. A parallelogram is a quadrilateral with two pairs of parallel sides. So that's what we're going to be talking about today, is not necessarily rectangles, but parallelograms, which all they have to have is two pairs of parallel sides. Here is a picture of one for your first example. So if you don't already have a piece of paper, grab a piece of paper, and calculator could help, but it's not necessary. So this is a parallelogram. The area formula is base times height, but we will simply be writing it as A, capital A for area, equals BH. B for base, H for height. We don't need the times sign because multiplying is a default operation in algebra. Then we're going to substitute the numbers that go in for the base and the height. So the base is going to be 6.3, and the height in a parallelogram is going to be the dotted line. The base and the height in parallelograms and some of the other shapes that we're going to be learning about, they need to be defined at a 90-degree angle. So that's what this little square means right here. That means this is a right angle, a 90-degree angle. These two lines, this baseline of 6.3 and this dotted line of 2.1, they are what are called perpendicular lines. They come together to form right angles. They intersect. So that's why this dotted line needs to be drawn here. So when you're looking for your height, it has to be this. I believe we discussed this in class already. Anyway, you take those two lines, or those two measurements of those two lines, and you multiply them together, and you get 13.23, and that is your area. The area is written as 13.23 with units squared. So in this case, it's meters. So we're going to write meters, and then we're going to write the little exponent 2 for squared. You could also write square meters if you want, or SQ space M for square meters. But this is the way our book teaches it. This is the way that I'm teaching it. And this is the way that you're going to see it next year, but you might see it differently depending on who's your teacher. But this is the way we're going to do it. So meters, little exponent 2. All right, next up, we need to learn that a square is a special rectangle in which the length and width are equal. For a square with side lengths S, A equals length times width, equals side times side, equals side squared. So that's just a kind of a long-winded way of saying that the area formula for a square is going to be A equals S squared. So here's a picture of a square. So the reason it's S squared is because it's side times side. So anytime you are multiplying a number by itself or to itself, you're going to, square it or go to the power of 2. So if you don't have the square button on your calculator, that's okay. You can simply just do 9.5 times 9.5. But what we have to do right now is do 9.5 and square it. And I think I forgot the little 2 that would belong right there. So on your calculator, type in 9.5 squared and hit equals, or simply do 9.5 times 9.5. They mean the same thing. That should give you 90.25 centimeters squared. Once again, it's an area answer, so your label needs to be centimeters squared with a little exponent 2. And finally, this is a little bit more algebra. We have a parallelogram and we know the area. The area is 98 square feet. Okay, besides it saying that it's the area, you'll always know that the number that you're being presented with is an area because it will either say square feet or feet squared. The base is 14 feet. What is the height of the parallelogram? So notice that area always gets a label of units squared, and bases and heights, because they are straight lines, are always going to just have the units. They're never going to be squared units or anything like that. So on your paper, let's put in this same formula. We're always going to use this for parallelograms. A equals BH. This time, though, we're going to substitute 98 in for the capital A. We know what the area is. We're going to substitute 14 in for B, which is the base. We know what our base is. Don't know the height. So you probably know what's coming next. We are going to divide both sides by 14 to isolate the variable h. We're going to do the inverse operation. This is classic chapter 8. Yeah, chapter 8 is when we learn this algebra. So this is how we write division in algebra, kind of like this fraction style. So we'll divide this side, 14h divided by 14 leaves you with just h. And 98 divided by 14 leaves you with 7. So you have 7 equals h, or h equals 7. So the bottom line is we just found the height. And that is not our official answer. What we have to do officially to give ourselves this answer now is to say, what are the units? So the official answer is 7 feet. The height is 7 feet. It's not feet squared because remember, we are only measuring in a straight line. And we discussed in class how when you get measured at the nurse or the doctor, you are not measured in square feet. You're just measured from your head to your toes. So it would just be you are 5 feet tall or however tall you are. So we're going to do that when we are looking for heights or bases. We just have the units. When we're looking for area, it's units squared.